is it's all about the surface area of a hemisphere and a sphere, right? Now the main problem here is the following. When you're talking about filling it up, so you imagine that this is like a water balloon, a spherical water balloon. How much water you can fill into it is the volume equation, where volume equals 4 over 3 pi r cubed. Okay? The surface area refers to the area you'd have to cover to paint it. So if you're painting the outside of the ball, so if you painted a football as an example, or any spherical object, that refers to as the curved surface area. In your notes, you'll only see two things. You'll see A equals 4 pi r squared, that's on page 8 of your tables, and you'll also see V equals 4 over 3 pi r cubed. Now, here's the problem regards your upcoming exam. The hemisphere doesn't exist in your tables, and most of you won't learn it off by heart. So what I think we should do is this, okay? Instead of having to learn anything new, simply the hemisphere, the volume, you just divide it by 2. So to get the volume of a hemisphere, get the volume of a sphere, and then just half the answer. Is that alright? Alright, so that eliminates the use for the volume equation. That's gone. That's a complete no-brainer. Now, the problem with the hemisphere is that, you know, when you slice it in half, you actually expose a new area. Okay? You expose half it, you expose a new circle to the open, okay? But if we're just talking about curved surface area, the curved surface area refers to the area on the curved part of the ball, or the curved part of the hemisphere. Technically speaking, you could shade the top region in red, you could shade the bottom region in black, and to find the curved surface area, all you have to do is half the area of the original sphere. Does that make sense? Half the area of the original sphere, you'll get the black part. But what's lacking is we haven't done anything about the new blue part that's been exposed. What shape is the blue part? A circle. And what's the area of a circle? Pi r squared. So get half the original sphere and then add on another pi r squared for the hemisphere. When you're doing these questions, guys, please assume that this information here doesn't exist, and you're working all of the top part. Is that okay? Otherwise, you're going to be really disappointed when you open up your tables and the information isn't there. Okay? Information that's in the exam is the top part, so we're only going to work using the top part. Okay? So that brings me on to the next part, where I only have access to my formula that's in my tables. So complete the following, which gives certain information for various closed standards. Give me a second there. What happens here, guys, is this. Complete the following, the information, and we're just going to highlight this word just to beat this point home. We're talking about spheres, okay? We'll do it in yellow because yellow's better. Spheres, okay? So what we have to do here is this. The first thing I want me to do is I'll do question 8 and I'll do question 12, and that should be enough to get us known. As for the volume, I go up here and go, okay, what's the volume? Volume is the volume formula, which is 4 over 3 pi r cubed. So I write down phi equals 4 over 3 pi r cubed. Next thing I do is write down 4 over 3. What version of pi am I using? Am I using the one that's in my calculator, or is it specifying I have to use a certain number? It's specified that it wants me for this question only to use 3.14. So I write down 3.14 in here. Now, radius squared, guys, gives me 9 meters. Now, I don't even write down the m, to be fair. Now, it's a volume. Is volume meters squared or meters cubed? Cubed. So meters cubed is automatically the unit. Just like gotta put this into calculator and just type it in like you would normally. 4 over 3. Then you write in pi. and then 9 cubed, and oh sorry, I made that mistake. I wasn't meant to use the pi from the calculator. I was meant to use 3.14, and go again. I got 3052.08. So 3.052, sorry, 3052.08 meters cubed. So my answer for that, 3052.80. Now, it is indeed. Everything that's on the top here is in the table. So that's the phi and the a. Now, it's now asking for the curved surface area. Oh, okay. It's now asking me for the curved surface area. I go back up to the top. I now choose the curved surface area formula, which is a equals 4 pi r squared. Like the last question, the pi value is 3.14. The r value, the r value is I'll say that was 9 cubed. Yeah, so 9 cubed. I'll say 9 squared. So put that into the calculator. 4 bracket 3.14 bracket 9 squared, and what you get is 1017.36. Okay, so 1017.36 meters squared or meters cubed. It's area, it's meters squared. So 1017.36. Okay. Now, does everybody understand that for all these questions, there are the two formulas you use, and the pi value you use is given to you here? Is that alright? Alright. Now, brings us on to the next one, and I'll just select that there. So we're now on to hemispheres next, and we only have that information to use. Okay. Now, the problem with the hemisphere is the following, and I'll do question 14 on this one. Okay, ready? Let's start off with the easy marks. The easy marks come in the form of the volume. Alright, it's a hemisphere. So what do I do to get the volume of a hemisphere? Using the information above. Get the volume of the full sphere, half the answer. So I'm going to write down phi equals 4 over 3 pi r squared. I'm going to find that answer, so I'm going to get 4 over 3 pi multiplied by 1.5 squared, yeah? Or 1.5 cubed. Sorry, it's 4 over 3 pi r cubed. Well, it says in the formula that it gives you. Okay, so what we get here is 4 over 3. The pi button is the yellow button just above the 10 power x one, so you have to shift pi. Then you press 1.5 cubed. You get 9 over 2 pi. You can leave it in terms of pi. Sometimes it asks you to leave it in terms of pi. So that is one of the answers. One of the answers would be 9 over 2 pi. It can also ask it for you in decimals, so you could also just press the change button, and you get 14.14. Shall we say, okay? So 14.14. Now, the hard part comes in, and they're both centimeters. That's centimeters cubed for that one, okay? The hard one is the curved surface area isn't that bad either. Remember what we said earlier? You just want half of the full sphere. So the area of the full sphere is pi r squared. Correct? Pi r squared, yeah, for the area of the full sphere. Okay. 4 multiplied by pi, what's the radius squared? 1.5 squared. Oh, lads. Yeah, no, sir, just one thing I forgot earlier. Did I half that at that time? Forgot to half it, didn't I? So, I should have divided it by 2. 9 over 4, so just when you're doing this, just make sure that you actually remember to half it at the very end. 7.07. Okay, sorry about that. Just make sure you half it. That's the danger. You might forget to half it. Okay, so try that again. 4 pi times 1.5 squared. 4 pi 1.5 squared, and you get 9 pi. That's the area of the full sphere, not half the sphere. So what do we need to do? Divided by 2. 9 pi over 2, or 14.14 yet again. So that's 14.14. Now that's great and all, but we're forgetting one thing. That's the curved surface area. It wants the total surface area of the sphere. What am I leaving out? Of the hemisphere. So if it's a hemisphere, I've forgotten about the top part. This part here is the red part. I've forgotten about the painting the blue part. So how much is the blue part going to be? Pi r squared. It's going to be the what's it called, the area of a circle, which is going to be pi times what's radius squared? 1.5 squared. Pi times 1.5 squared. Anybody? In decimals. Pi pi times 1.5 squared, and that equals 7.06. Yeah, that's 7.06. Do I need to half this one? No, because it's the circle that was exposed. Okay, so 7.07. Add that onto what? Add that onto the curved surface area, which is 14.14, and you get your total surface area of 21.21. Okay, for homework tonight, we're going to go for the the even numbers. 14, 16, 8, 10, 12, 14, 16. So the homework tonight is 14, 16.